Let's talk about properties of logarithms. So I've written up 3 exponent properties. We're thinking about these in terms of inputs and outputs now. Notice what happens. If you have these 2 inputs added, input added, the outputs get multiplied. So outputs multiplied. Here, inputs subtracted, outputs divided. Inputs multiplied, outputs as exponents, okay? So imagine what would happen if logs came along. Now remember what a log is. A log is the inverse function for an exponent. You should expect the exact opposite to happen. So if you were to guess, without doing the math, where these things should go, you should expect, well, if the inputs are multiplied, the outputs should be added. And you'd be right. Let's look and see how those properties work. Now, before we get going, there's one more property that we need. Just remember, because they're inverses, if you ever see anything like log base a of a to the whatever, we'll put a to the t, just equals t, right? Log base a of a to the t, these are inverse functions, and so we get back t. So with that, let's see what we get. Here are what the rules are going to give us. They're going to give us something for when we have log base a of x, y. Log base a of x over y. And log base a of x to the n. Okay? So let's look at this one to start with. Let's imagine I was trying to, say, prove that something was true about that. I might say, well, I'd like to think about log base a of x and log base a of y. And so I'm going to call those things something. Well, this is hopefully a variable. So we'll say that's u. Let's call this v. That allows us to think, well, if these are the logarithmic equations, what would the exponential equation be that encodes the same information? Well, this would say a to the u equals x. This would say a to the v equals y. So with that, then let's think about what this would be. Log base a of xy, well, x is just a to the u. Y is a to the v. Well, if you have a to the u times a to the v, remember by exponential properties, that's supposed to be, and always is, a to the u plus v. Well, but remember, this is why I put this in, log base a of a to the anything is just that. These two things undo each other. So log base a of a to the u plus v is just u plus v. Okay? Well, what's u? U is log base a of u of x, x. And v is log base a of y. So log base a of xy is equal to log base a of x plus log base a of y. Notice what we said. These inputs are now multiplied, the outputs are now added. Well, similarly here, inputs were subtracted, outputs divided. If the inputs are divided, you should expect what we're going to get is we're going to get the outputs are subtracted. If the input's an exponent, the output is going to be multiplied. So these are the other rules here. Now you can actually get these rules. What you would do here, you would divide, and I'd encourage you to do this. You'd have a little subtraction formula there, and all would work out well. You can even modify it a little bit to get the third property. But those are the 3 properties. I put up 2 example problems. Now, these get used to solve all sorts of mathematics, but just to start with, there are 2 basic kinds of problems that we have: expanding is the first kind. If you get all of these together, you can use the logarithmic properties to expand it. So you get log base 7 of x plus 2 log base 7 of y minus log base 7 of z, because that's in the denominator. Here, if you have all of these terms, you can condense it into a single logarithm by doing the exact opposite. Log base 4, notice that this is going to be in the numerator because it's positive or added. This is going to be in the denominator because it's subtracted. That third power, using this rule here, makes it y to the third. This is in the numerator because it's added, but a 1/2 power is the same as a square root. And so this condenses to that piece there.